evaluating the second formula now. Here we are having I integration is equal to dx upon square root of x square minus a square. Okay. Now let x is equal to a secant theta. Now differentiating with respect to theta, we are having dx is equal to a secant theta tan theta d theta. Now putting the values in the question, we are having integration of a secant theta tan theta d theta upon x square a square secant square theta minus a square. Okay. So now this becomes integration of a secant theta tan theta d theta upon a square secant square theta minus 1. Is it clear? So now this becomes integration of a secant theta tan theta d theta upon a tan theta. Secant square theta minus 1 is tan square theta, and now we are left with secant theta d theta. One thing. Now integration for secant theta d theta, log mod of secant theta plus tan theta plus C1. Okay, let it be C1. Log integration for secant theta is log secant theta plus tan theta plus C1. Now we have to reduce the question in this format, isn't it? So now our question becomes log mod of secant theta plus, now tan theta, can we write tan theta as under the root secant square theta minus 1 plus C1? Now we have taken x is equal to a secant theta. A secant theta is equal to x, secant theta is equal to x upon a. Okay, so now let's put this value. Now we are having log mod of x upon a plus under the root secant square theta, now x square upon a square minus 1 plus C1. Now what this becomes? Now this becomes log x plus x square minus a square upon a plus C1. Now using the rules for logarithm, what we can write it now? Can we write like this? Log x plus under the root x square minus a square minus log plus C1. Is it clear? So finally what we are having? Log x plus under the root x square minus a square plus c. Okay, log a is a constant term, so we have merged it where c is equal to c1 minus log mod a. Okay, and the formula was log x plus x square minus a square plus c. Proved. So like this we can easily prove this question.